Well, thank you very much for joining us today, Joel.
Thank you.
So first of all, tell me how it is that you got into space and what it is that you do.
Yes, I'm an engineer for Harris Corporation, and Harris does advanced communications, hardware and software for NASA and DoD agencies. And how I got into NASA was actually pretty interesting. It was being the right person in the right place at the right time. I joined Harris in 2003, and that was right before Bush announced the vision for space exploration. I think it was January 2004, I think. So I was in the company for about 6 months and was asking, hey, you know, what's going on with NASA? How do we get more involved? And then once the exploration vision was announced, my CEO said, hey, you're the guy that's been asking the questions, so you're in charge of making it happen. So I had the great pleasure and honor of kind of starting up Harris's new business efforts at NASA. And here we are, I guess, 9 years later. So it's been a great opportunity.
What is your specialty with the communication systems?
Yeah, so what I jumped into first was looking at advanced communications needs for the future vehicles, right? So Constellation was originally, Moon, Mars, and beyond, and Harris had a lot of innovative ideas on how to provide cheap communications and reliable communications for the vehicles and ground systems for those great distances. So what we did is we started off with some technology projects, and which were funded by NASA, which was very exciting. So we got, I got to work with JPL and Goddard Space Flight Center and Johnson Space Center, and work with people that have been, mission focused for a long time. And so I was the program manager for a lot of those technology programs. And I got to bring some very smart engineers and have them sit down with those mission specialists within NASA and create some new ideas, for the future. And so as, kind of Constellation has kind of morphed, and as the new programs have come on board, a lot of those ideas are still existing. And we're hoping that as the vehicles kind of come online, that a lot of them will be implemented. But since then, what we've done is I've gone on to the software side, and we have a command and control product that's being used to control Orion, and as the telemetry and control system for Kennedy Space Center and Johnson Space Flight Center. So the nice thing about what we're doing is we're providing the same architecture and system for KSC, JSC, and the flight vehicle, and really for the first time, all of those entities are going to be using the same software for its command and control. So it's saving the agency money, and they're using a commercial product to do that. So each of the centers don't have to develop their own system. So it's nice, and that's a beautiful thing, I think, about what's happening with the commercial side. Now that commercial is pushing and taking off on the vehicle side, it's forcing NASA to say, well, gee, if we're going to work with commercial companies for human spaceflight, then we can adopt commercial products for a lot of the basic technology needs that we have and we use every day. So it's on one side, it's kind of this very difficult thing for NASA to do, to work with commercial companies kind of on a large scale, but also on a small scale it's difficult for them to do that too, because a lot of the NASA folks want to kind of invent things from scratch, make sure they know that it works perfectly. Well, sometimes just working with a commercial system and then relying on industry to, in a cost-effective manner, make things work as best as it can is also hard to do, but also gives a big benefit in terms of cost-effectiveness. So that's kind of what we're doing.
Absolutely. Well, in regards to communication, let me ask you a hypothetical question.
Sure.
If a spacecraft, once we're doing more interplanetary stuff, if they were to drop a communication satellite, halfway or something as like a waypoint, would that be able to solve a lot of the problems of time delay?
Interesting question about time delay. What we have proposed is the systems that are currently used were basically invented for the shuttle era, and actually Harris was involved in inventing some of those systems. And from a time delay perspective, there are a lot of new technologies that are being investigated, from using like laser communications. The optical communications is kind of the big push now, and MIT Lincoln Laboratories is involved in the study, and Harris is helping out in some aspects. I'm not sure that we're going to be able to get around some of the time delays when you're talking about Mars, that sort of thing. But what we were looking at is basically total coverage and lack of dropouts. So what we had proposed is basically a ring around a spacecraft that provides total coverage depending on where or what the vehicle is doing. And so the way that the systems are currently designed is that they switch from one system to another as a vehicle turns. And what happens is that there's a little bit of a dropout, but depending on where the spacecraft is, the communications can be diminished. But Harris came up with a unique technique that allows all of the communications elements and transponders to be actively engaged, and then combine the signals together so you have a stronger signal. So what happens is that as the spacecraft moves, the more transponders that are in view, the stronger the signal is, and that provides a better, kind of communication capability and suite if you're looking at things like HDTV, that sort of thing. So what NASA's limited to now is very low data rates because of these communications issues. But what we said is that if you can do this and implement this new system, you can have HD quality, video and audio, and bring back, some pictures in real time or near real time that provide a better, better product. So from a time delay perspective, I'm not sure you can quite get around that, although there are some investigations being done in faster than light communications. And I'm not involved in any of those, but you're right. Kind of having different relays in different places does help keep the quality, of a signal up, get the information back faster, and provides better communications. But what NASA is investigating is optical communications from, kind of low Earth orbit out. And if that's implemented, I think the plan is to have it implemented by 2030. And if that's implemented, that will mean much higher data rates for future missions.
That'd be awesome.
Yeah, I think so. I mean, HGTV on Mars, that'll be real neat. Instead of still pictures, right? So right now we get still pictures and we look and we say, okay, that's really cool. But if we're going to send people there, you don't want to have people sending back still pictures. You don't want to have people sending back HD video. And to implement those systems, you have to start now, right? We don't want 2025, we're at an asteroid or something like that, and you're sending back still pictures. That doesn't really get the, humanity engaged, so.